Good morning, students. Today, in the operating system lecture series, we will discuss disk management. So, in the disk management, the operating system is responsible for several other aspects of disk management, that is, disk formatting, boot block, bad block, okay, and so on. So we will discuss these points in the disk management. Let's say we will discuss also the swap space management, disk reliability. So first of all, we will start with the disk management, and the disk management we will discuss uh, disk formatting. So as you know that before a disk can be used, it has to be low level formatted, which means laying down all of the ends of each sector. Okay, so including the headers and trailers, marking the beginning header and the trailer are the linear sector numbers, and error correcting codes, which we will, in the short we will write ECC, that is the error correcting code, which allows damaged sector to not only be detected, but in many cases for the damaged data to be recovered, depending on the extent of the damage. Okay. So when the controller writes a sector of data during normal input output, the error correcting code is updated with a value calculated from all the bytes in the data area. When the sector is read, the error correcting code is recalculated and is compared with the stored value. If the stored and calculated numbers are different, this mismatch indicates that the data area of the sector has become corrupted and that the disk sector may be bad. So the error correcting code is an error correcting code because it contains enough information that if only a few bits of data have been corrupted, the controller can identify which bits have changed and can calculate what their correct value should be. So the controller automatically does the error correcting code processing whenever a sector read or written. Okay, so this is, the, you can say, the function of the controller which takes care of these things. And sector size are traditionally 512 bytes, but may be larger, particularly in larger drives. So error correcting code calculation is performed with every disk read or write, as we have discussed, and if damage is selected but the data is recoverable, then a soft error has occurred. So that is called a soft error. Soft errors are generally handled by the onboard disk controller and never seen by the OS. Once the disk is low level formatted, the next step is to partition the drive into one or more separate partitions. As you know, when you will purchase a new laptop or the PC, so first of all you are, the formatting the disk, then you are lower level formatting the drive like C, D, E, F, G. So in this way you are, formatting the drive into one or more separate partition, so that in the one C drive you can put some software, in the D drive or E drive you will make some data for particular data, or you can say some personal data you can keep. So this step must be completed even if the disk is to be used as a single large partition. Okay, so if you are using it as a single large partition, so that is also a necessary. That is at a fixed location that the processor can start executing when powered up and or reset. And Martini bootstrap loader program small, for example, Amazon program. Okay, that is a dual boot. So that is also your. Now there is one more, that blocks. Okay, bed blocks. No disk can be manufactured to 100% perfection. Okay, and all physical objects wear out over time. For these reasons, all disks are shipped with a few bed blocks. Okay, all disks are shipped with a few bed blocks. You know, when the disk is coming, it is also having some bed blocks. And additional blocks can be go bad, then the entire disk will need to be replaced. But a few, okay. So if the old days, bed blocks had to be for manually formatting of the disk or running certain disks to read the data of them. One last time, through repeated tries. Then the bed blocks would be mapped out and taken out of future service. Sometimes the data could be recovered, and sometimes it was lost forever. Disk analysis tool could be either destructive or non-destructive. So modern disk controller make much better use of the error correcting code so that bad blocks can be detected earlier and the data usually because blocks are tested so often errors can be detected before the write and the data simply written to different sector. Okay, now we will come to the swap space management. Modern system typically swap out pages as needed rather than swapping out entire processes. Hence, the swapping system is part of the virtual memory management system. Managing swap space is obviously an important task of modern operating systems. So, the amount of swap space needed by an operating system varies greatly according to how it is used. Some systems require an amount equal to physical RAM. Some want a multiple of that. Some want an amount equal to the amount by which virtual memory exceeds physical RAM. And some systems use little or none at all. Some systems support multiple swap spaces on separate disks in order to speed up the virtual memory system. In the swap space location, so swap space can be physically located in one of the two locations. One as a large file, which is a part of the regular file system. This is easy to implement but inefficient. Not only must the swap space be accessed through the directory system, the file is also subject to fragmentation issues. Caching the block location helps in finding the physical block, but that is not a complete fix. As a raw partition, possibly on a separate or little used disk, this allows the operating system more control over swap space management, which is usually faster and more efficient. Fragmentation of swap space is generally not a big issue, as the space is reinitialized every time the system is rebooted. The downside of keeping swap space on a raw partition is that it can only be grown by repartitioning the hard drive. Okay, so this is one of the example of the swap space management. In this, you can see that there are swap partition or swap file. You can see the page slot, and this is the complete swap area. And swap maybe is also having the page number, that is the 0103 like this. And in this you can see the pre-processed swap maps are used by the kernel to track swap space use. The segment is a fixed size, so its swap space is allocated in 512 KB chunks, except for the final chunk, which holds the remainder of the pages in 1 KB increments. Okay, so this is how the swap space management is done. So this is the map thing. Now there is one more thing that is called the disk reliability. So the disk drives have continued to get smaller and cheaper. So it is now economically feasible to attach a large number of disks to a computer system. Okay. So the general idea behind RAID, that is, the RAID is the redundant array of independent disks, is to employ a group of hard drives together with some form of duplication, either to increase reliability or to speed up operations. So we are using RAID to increase the reliability or speed up the system. RAID, that is called the, I have also redundant array of independent disk. Earlier it was also called redundant array of inexpensive disk. So now it is known as redundant array of independent disk. Okay, and this disk reliability improves the reliability by redundancy. That is also called the disk mirroring. The disk mirroring, because you know disk mirroring, and there is one more word that is called the stripping. So uh, stripping is multiple data by stripping data across multiple. In its data stripping consists of each byte across multiple disks. Such stripping is called bit. So there could be a bit level stripping and stripping. One is data stripping, that is bit level stripping. Another is the stripping does not need to be at the level of bits or a byte. For example, in block level stripping, blocks of a file are stripped across multiple this system to small access and reduce the response time of large accesses. There are also red labels. There are red 0, red 1, red 2, red 3, red 4, red 5, and red 6. In the red 0 label refers to the disk array with stripping at the level of blocks but without any redundancy. Red label 1 refer to disk mirroring. Okay, you can see this is the disk mirroring. Red label 2 is also known as memory style error correcting code organization. Red label 3 uh, or bit interleaved partition organization. Red label 4 or block interleaved parity organization. Red label 5 or block interleaved distributed parity. Okay, and this red label 6 is also called the P plus Q. That is called the P plus Q redundancy scheme. And there is also red label 0 plus 1 refers to the combination of red label 0 and 1. So this is the red redundant array of independent disk to improve the the reliability and the speed of the disk. These are some of the references. And thank you. In the next topic, we will discuss information and management. Thank you. Thank you for listening this lecture.